Okay, so in the last video, we were looking at the domain of the function h from Chapter 2 of Investigations in Algebra. And we saw that h of 2, that 2 is in the domain of h because we could execute it. And if we step through it, we see that we kind of back up until we get to x equals 0, and then once we get to x equals 0, then we can start returning and working our way back, getting return values and working our way back until we get to 10. So it's basically a 4, and then we keep adding 3's until we get back up to 10, right? So let's look now at something that doesn't work. So I'm going to stick in a -1 here. And right away it says stopped after 300 steps to prevent a possible infinite loop. So let's see what that's about. Let's try. If we go in there once, we set x to -1. Well, x is not a 0, so we're going to go forward. Now x is -2. Well, x is not a 0. X is -3. We're never going to get to 0, are we? So that's what the infinite loop is about. Okay? So, so negative numbers are not going to work. Right? Negative integers. If we have -1, -2, and so on, those are not going to work. So let's take a look at one other thing that's and in general, when you see something that is a recursive function that backs up to a particular value, then you have to worry about, what happens if you start out below that value. Now one fix to this might be if we just said this. If we said if x is less or equal to 0, return 4, right? Then those negative integers would be in the domain. But we have x equals. Okay. And in fact, that's a common programmer trick, to just stick that less in there, just to keep yourself from getting random errors. But I'm going to leave this for now because I want to look at one other possible problem, which is h equals 2.7. What happens in that case? Where it's not an integer value that we're getting, but a float. Oh, this one says infinite loop too. So let's see what's going on with this one. So we start out with h being 2.7. And then it's not 0, so we subtract 1, and it's 1.7. That's not 0. 0.7 is not 0. Oh, now we're at -0.3. Now we're at -0.13. So we're going to keep going again. We're going to keep going forever and ever and ever, and never get back to build up our value, because we kind of skipped over the 0 case here, right? So that's another possible problem where you have something where you're trying to end exactly at a particular value. And again, if we back up for a second, this could also be fixed with the less or equal than, right? Because then as soon as we get to, let's back up, as soon as we get to 0.03, well, that's less or equal to 0, isn't it? So then that'll return a 4, and then we can back up and actually get something. Okay, and notice that we got an integer output even though we had a float input, because We're returning an integer and we're adding integers all the way to get all the way back. Okay, so that's general stuff to look for whenever you see. That's one of those things you got to worry about whenever you see these equals equals. It's a recursive function and it's backing up to a particular value.